At the Vivian Engineering Center in a fourth floor lab, a team of engineering students has been prepping tirelessly for upcoming competition in June.
It's a competition taking place nationwide. It's going to be at the Johnson Space Center in Texas in the beginning of June. Essentially, it's 8 different universities from around the country building a rover system that has to be able to navigate a certain terrain that's essentially simulated to simulate a Mars-like environment. Um, Effectively, your rover has to be built, or a rover system. It could be multiple rovers. Has to be built within certain design requirements, in relation to dimensions, weight, and mission profile. So effectively, the rovers are built with a robotic arm. That's an imperative, design requirement. Is that your rover has essentially a sampling system, sample acquisition system that it can pick up rocks with, and place them on board. And also, your rover system has to be able to relay live video and audio feed to the home university. Because while the competition is taking place in the Johnson Space Center in Texas, the rovers are going to be controlled from here using the internet, using computers. So effectively, that's the competition. So our rover is essentially it's a multi-rover system. It's a twin rover system. The rovers are built, each one tailored to a specific kind of environment. One rover is essentially built to navigate more of a rocky area with some, hard-packed dirt, and the other is built to navigate sandy environments with, slight slopes here and there. So each rover is essentially, kind of fitted with certain, tire treads or, height that will optimize it for its environment.
Basically, what happens is someone presses a command on the control client, which gets sent to the server, which functions more as a router. The router routes the data to the correct rover, which then is received on the Raspberry Pi on the rover. The Raspberry Pi then takes this data and then forwards it via serial to the Arduino, where the Arduino then takes this data and then uses it to perform some kind of output. The reason we use the Arduino for this output is because, being a microprocessor, the Raspberry Pi is very sensitive to voltage fluctuations. So basically this isolates the main computer, the brains of the system, from the actual muscle of the system, being the Arduino.
Our wheels are put in opposite lock with a differential mechanism that essentially ensures that whenever you're going over a rock, you have at least 3 wheels in contact with the ground at all times to ensure traction. So that's kind of the basic backbone that we've gone behind mechanically. But there are other aspects of the grading criteria, such as things like having done community outreach, as a team through the building process. We also have a technical presentation and a poster presentation that we have to do. There are multiple grading aspects that they consider. But for the most part, yeah, I mean, picking up how many rocks you pick up kind of dictates how well you've done. Essentially, how robust the rover system you've built.
And I think it's just pretty cool just because, we're getting the opportunity to be able to work on this, which is, I mean, it's something that's been done before, but it's still a pretty tough task. um, what else I could say about it is pretty much that, I don't know, I personally enjoy being able to work in this type of environment, getting together with students, and people, having certain deadlines they have to meet, and kind of makes you feel like what I'm learning in engineering is being applied instead of just going to class and, just trying to get a good GPA.